Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is section 4.4, solving multi-step inequalities. To solve multi-step inequalities, it is the same way you solve multi-step equations, which we have gone over. Just remember our one special rule. If you multiply or divide by a negative number, you must switch the inequality sign. So let's look at A. We're going to go first step, add 4. That would leave us with negative 3x is less than or equal to 18. Go ahead and divide by negative 3. So x, remember when I divide by a negative, I have to switch my sign, will be greater than or equal to negative 6. Okay? B. The first thing I want to do here is I want to make my variable on the left-hand side just in case I ever have to graph it. So I'm going to switch the entire inequality. The arrow is still pointing at the 5. I'm going to subtract 7. That would get me negative 2n is greater than negative 2. Divide by negative 2, divide by negative 2, n would be less than 1. All right? On to example 2 where we actually have the multi-steps here. First thing I want to do, if this was an equation, I would do what first? I would distribute. So 4 times 6, 4 times negative x, give me 3x plus 24 minus 4x is less than 2. Okay, what is 3x minus, well, from here I'd want to go ahead and combine like terms. So 3x minus 4x would be negative x plus 24. Is less than 2. Subtract 24, subtract 24. Negative x is less than negative 22. Now I need to divide by negative 1. So x would be greater than 22. Okay? On to b, I need to distribute again. So 5 times negative 3, 5 times d. That would give me negative 15 plus 5d is less than or equal to 3 times 3d, 3 times negative 2. 3 times 3d would be 9d. 3 times negative 2 would be negative 6. Again, I never want to make my variable negative, so I'm going to subtract the 5d when I combine like terms. That would give me negative 15 is less than or equal to 4d minus 6. Add 6. Negative 9 is less than or equal to 4d. Go ahead and divide by 4. I would have negative 9 over 4 is less than or equal to d. Do I like to have an inequality where my variable ends up on the right-hand side? I do not, so I need to rewrite my inequality as d is greater than or equal to negative 9 over 4 because I want my arrow still pointing to the negative 9 over 4. On to some application problems. Here we need to define a variable, write an inequality, and solve. So Brian pays $4 to rent skates every time he goes roller skating. He thinks he can save money if he buys his own skates for $45. So $45 is going to be on a side by itself. He wonders, when is the cost of renting skates more expensive than buying a new pair? Does that say at least as expensive or at most or anything along those lines? It does not. What that says is more expensive. So that means that whatever I am setting on the other side of the inequality from the 45 will just be greater than the 45. Now I need to go ahead and define a variable that will be renting skates, or the number of times I rent skates. How do I figure out how much it costs for a certain number of time of renting skates? That would be 4 times the number of times I rent the skates. From here I can divide by 4. So R would be greater than, it'd be 11.25. Can you rent skates just a quarter time? You cannot. So I need to, from here, figure out well, was 11 times renting the skates more expensive than the $45, or would it be 12 times? The 12th time that he rents the skates would be more than $45. It would be the 12th time, so it would be 12 rentals. So my R would be 12 rentals. Moving on to the back. Dawn's neighbor will pay her $13 to mow the front lawn and $4 per hour to take care of the garden. Just because right away it says per hour, I know that my variable is going to be the number of hours. How can I write $4 per hour algebraically? It would be 4H. If she mows the front lawn, what is the least number of hours she has to work on the garden to earn at least $25? Well, 25 is going to go on the side by itself, right? And it says at least, so my other side needs to be greater than or equal to that 25. Well, how can I figure out how much or how many hours she needs to work if she mows the front lawn and she gets paid $4 an hour? Well, it would be $4 times the number of hours plus the $13 for mowing the front lawn. From here, I can subtract 13. It would be 4H is greater than or equal to 12. I can divide by 4, divide by 4. H needs to be greater than or equal to 3 hours. So she has to work at least 3 hours to earn $25. Okay? The weight of a carton of books to be shipped must be under $44. Or 44 pounds, I'm sorry. It says it must be under 44 pounds. So that means I need to be less than 44 pounds, right? If each book weighs 0.6 pounds and the carton itself weighs 2 pounds, what is the greatest number of books that can go into the carton? Well, how can I figure out what the weight is of just the books? Well, I'm going to need a variable, so we'll make the variable books. It would be 0.6 times the number of books. How can I figure out the total weight of the carton and the books? Well, it would be the weight of the books plus the 2 pounds for the carton. I need to subtract 2, subtract 2. That would give me 0.6b is less than 42. You divide by 0.6, divide by 0.6. So b would be less than, at this point, it would be 70 books. So the greatest number of books that she can send, or that we can send, would be 70 at one time. All right, on to the most difficult problem we have so far. The freight elevator of a building can safely carry a load of at most 4,000 pounds. How can I say with inequality terms and an inequality at most 4,000? Well, that would be less than or equal to the 4,000 pounds, right? A worker needs to move supplies in 50-pound boxes from the loading dock to the 4th floor of the building. What's the only thing there that really matters? Well, it is the 50-pound boxes. The worker weighs 160 pounds, and the cart he uses weighs 95 pounds. So between the weight of the cart, the weight of himself, and the weight of the 50-pound boxes, it needs to be less than or equal to the 4,000. Right? So my variable to figure out the weight of however many boxes he's going to take, I need a variable of b for boxes. It would be the 50 pounds times the number of boxes, plus the 160 pounds he weighs, plus the 95 pounds that the cart weighs. All of that needs to be less than or equal to the 4,000 pounds. From here, what I can do is go ahead and combine like terms. So it would be 50b plus 255 needs to be less than or equal to 4,000. If I subtract the 255 from both sides, that would be 50b needs to be less than or equal to 3,745. Divide by 50. So the number of boxes needs to be less than or equal to 74.9 boxes. Well, since I can't have 9/10 of a box, the number of boxes, can the number of boxes or the total weight exceed the 4,000 pounds? It cannot. So I'm going to round down. So the number of boxes needs to be less than or equal to 74 boxes. All right? All right, moving forward. The worker must deliver 310 boxes to the 4th floor. How many trips must he make? Does this say anything about at most, at least, least, most, has at most, has has to spend or anything along those lines. It does not. So this is actually going to be an equation. So I'm going to make t the number of trips that he needs to take. We know that we have 74 boxes is the most he can take at one time. So it'll be the 74 boxes times the number of trips needs to equal 310 boxes, right? Well, from here I can take and divide by 74. So the number of trips would be equal to 4.19 trips. Well, here's the question. Can I take just 0.19 of a trip? If I take even 0.19 of a trip, that's going to be a full trip, right? So t would equal 5 trips. That is the end of our lesson. The most important thing to remember here is that when we are solving multi-step inequalities, it is the same thing as solving multi-step equations. Remember that if you multiply or divide by a negative number, that you are going to flip your inequality sign. Thank you very much for watching the video. If you have any questions, make sure you bring them to me tomorrow, and have a great day.